Hello and welcome to your first session with sklearn. So today we are going to build together a model which is the k-nearest neighbors model. But before that, let us do a bit of a recap for what you already seen in the previous video or lessons. Okay, so let us start with what is supervised learning. So in supervised learning, machine receives data that are characterized by a variable x and annotated with a variable y. So in machine learning, we call x as features and y as labels. In supervised learning, the goal is for the machine to learn to predict the value y according to the features x given to it. So first of all, we need to create our dataset and then associated to that dataset our labels, which we call the targets. Okay. To do that, we start by giving or to specify the model that the machine must learn. So we have many types of models in machine learning. We need to specify, is it linear model? Is it a decision tree? Is it a neural network, etc. Additionally to the model, we need to specify also the hyperparameters. So, for example, how many branches there must be in the decision tree, how many neurons there must be in the neural network, etc. So, once we've done all that, the machine will start working. It will use an optimization algorithm to find what are the parameters of the model that give us the best performance for the data. This is what we call the training phase. Okay, so once we've done with the training phase, we will be heading to the testing phase, and then our model will be ready to use. Now, when the machine receives new data, which are this time without labels, okay? So we don't have the labels, we just have data without labels. The machine will use the model that we've trained and we create to predict what are the values of y. Okay, so after the model is trained, when I give the model this square, it will be able to classify it and to know that is a square. Okay. Now, thanks to these methods, we can resolve a regression problem when y is a continuous variable, means a quantitative variable. Okay, so if you have, for example, the price of houses, the temperature, etc., and we can do the classification problems when y is a discrete variable, means qualitative variables like this one. We have several shapes. Okay, now let us talk about the k-nearest neighbors. So KNN is one of the simplest yet powerful supervised learning algorithm. So it is widely used for classification problem. The data point in this algorithm is classified on the basis of each k-nearest neighbors. So what does that mean? For example, we have here a new example to classify. We have this point to be classified whether it is or it belongs to the class A or the class B. So what we will do is to calculate the distance between that point and the other points. And then if we have, for example, we will put k equals to 3. So we are interested in the 3 nearest neighbors of that point. We will be interested with the majority vote of those nearest neighbors. So here we have 2 green neighbors and just 1 red neighbor. So we will say, or we will decide that this point will be or will belong to the class B. Okay, then I hope that's been clear. Let us start building our KNN model using sklearn. So to do that, we need, of course, a dataset. I choose to use the Titanic dataset, so it is a very famous dataset that is available on Kaggle. Okay. I can just upload it from Kaggle, or I just can upload it from libraries like Seaborn Library, for example. Okay, so the Titanic dataset is pretty famous, like I said. It exists in the Titanic machine learning competition. Okay, so the competition is simple. We use the machine learning to create a model that predict which passengers survived the Titanic shipwreck and which one doesn't survive. Okay, so we are using this dataset. I'm just going to upload that from Seaborn. Okay, so let's import our libraries. Okay, so first of all, let's import Seaborn because we are going to upload the dataset from here, or to load the dataset from here. I'm going to call it Titanic. Here we are going to need the Titanic. Okay, so if you want to know the other names of the dataset that Seaborn has, we will use seaborn.get dataset names, and you will find the other names that exists in this library, like for example Iris dataset, etc. Okay, here we are going to use Titanic, like I said. Okay, so let's discover what is this dataset. First of all, let's see the shape. Okay, so we have 15 features and 819 symbols. Okay, let us see that. Titanic.head. So we are using pandas. Okay, it is a data frame. So we treat that Titanic as a data frame. Okay, so this one will we will have a data frame if we use this one, this code. Okay, so Titanic.head. This is the dataset that I'm having. Okay, so the first column, as obvious, it will say if we survived or not. Okay, so we have 0 or 1. 0 if we don't survive, 1 if we survive. P class is the ticket class, the sex of the passengers, the age, the part, the fare, embarked or not. Okay, the class, who, men or women. Okay, so we have several features that we think that they are very useful to see if the passenger will survive or not. Okay, so if you want to know more about this dataset, you can go here, data, and you will see. Okay, you have here. Yeah, here we have the definition of each variable. Okay, and the meaning of each column. Okay, guys. So here, if you want to discover this dataset, okay. So let us return to our basic goal. We have this dataset. We have several features. Okay, and we have some samples. Okay, as I explained here, the first thing to do is to split my data frame as the X and the Y. Okay, the labels and my training data set. Okay, okay, so here I am going to just take few columns so that it won't take a lot of time dealing with all the features. And if you want, you will repeat this work with all the columns. Okay, so we have some cleaning data set that we need to do. After that, we will create the model. Okay, I'm going to select some features. I will call it Titanic also. Titanic also will be the data frame Titanic with those columns. Okay, so I will select, of course, the survived column. This is my target that I want to predict. Okay, the P class, the sex, and the age. Okay, so this is my new data frame. Let us see this. Okay, so this is a part of the dataset that I'm going to work with. Okay, so let us see, for example, Titanic.info. Okay, so here we have some missing values. Okay, some null values. Yeah, and we have here an str or a string type that we want to change it to an integer or a float type, because as you know, the computer don't understand words, it only understands numbers. Okay, so let's do that. First of all, let's drop the missing columns or the missing values. Okay, so did you know why I get that I have some missing values? Because all the shape or the lines that I have is 891, and here I have some missing values. Okay, so I'm using Titanic.drop now. So I'm not going to replace this because I don't have so many values that are missing. Okay, okay, so I'm dropping the lines, and in place equals to true. Okay, now the shape will change. Yeah, I will have 714. Okay, so after this I need, as I said, to replace the this female and male with numbers, because computers only understand numbers. Okay, so that will be the column sex. So Titanic will be replaced. We are using replace function. Okay, I'm going to replace male and female with 0 for male and 1 for female. Okay, so in place equals to true, and that's it. Let us see Titanic.head. So this is my new column with the values 0 and 1. Okay, so the next step will be to specify my X and my Y. Okay, so Y is the target, so the target column is survived, so this is why I'm putting Y equals to Titanic. I'm selecting the column survived, this one, and X will be Titanic, all the data frame, but with dropping the column survived. Okay, so survived is already in Y, I don't need it in my X, it will be survived. So this is the first step that you should all do before starting or building the model, is to separate the target from the features. Okay, and axis equals to 1 because I'm talking about column, so column is 1 and lines is 0. Okay, now I have my X and my Y. If you want to see it, this is the Y. It is a vector with or a data frame with 0 and 1, and my X is this one. This is the data frame without the labels. Okay, now let's do the most important part, which is creating the model. all algorithms of machine learning have already been implemented with scikit-learn. So we just need to do this. So it's the same thing for all the machine learning algorithms that are already implemented in scikit-learn. sklearn dot neighbors import k neighbors classifier. Yes, this is the one. Okay, so here we have my classifier. To create the model, I just use this model equals to k neighbors classifier, and that's it. It is as simple as this. Now in this parenthesis, I can put the number of neighbors that I need, okay? But it is, by default, it's going to be 5, I think. Okay, so let us see. Let us see this function from sklearn. Okay, so this will explain in details this class from sklearn. Okay, so these are the different parameters that you need to specify, but we can just use them by default. So the number of neighbors that we are using is 5, but after this we are going to change a bit this number to see what's going on. Okay, so here we'll explain in details the matrix and the parameters, etc. Okay, so if you are interested, you can see this. Okay, so let us move on, and then I will go back to the number of neighbors. Okay, so as I said, for this module, I can here put any classifier that I want. Okay, any model that I want. Okay, so it's going to be the same way for all the models after this. Maybe the changes will be in the parameters that I will put here. Okay, so the next step after creating the model is to fit the model. So we are going to fit the model with the X, which are the features, and the Y, which are the labels. Okay, now to do that, we are going to use model.fit with X and Y. Okay, it is as simple as that. And then after fitting the model, okay, so I have the model that has been fit and has been trained. Okay, so fitting means training the model. We now want to find out the score that we have. So model.score. So model.score, if I give it X and Y, I will have this score. Okay, so this score function will evaluate my model, and it says that 80% of the time my model is predicting correctly. Okay, means that it can predict whether passengers will survive or not. To know the passengers that are survived or not, we can use, for example, model.predict X. Okay, so this will give us the prediction of my model to the passengers. Now in this example, I am using the whole dataset, the whole X, to train my model, and then I tested my model, or I evaluated my model for the same dataset, and this won't give me a really reliable score. Okay, so to have a really reliable score or a really correct score, what I'm going to do is to split my X into training set and testing set. Okay, so the training set will be just to fit this model, and the testing set will be just to test my model. Okay, so the model will be tested on a data set that it never seen before, and that will give me the correct score. Okay, so to do that, I'm going to reinitialize my model. Okay, so here, if I run this, I have a model, just the initialization of the model, so it's not trained. And then I will just do this. And then I'm going to split my data. Okay, so to do that, I'm going to use the train test split from scikit-learn. Okay, so from sklearn dot model selection import train and test split. Okay, so it's a function that is ready and already implemented in scikit-learn that will split my data. Okay, after that I'm going to call it train xtrain, the x that I'm going to train my data with, xtest, the testing data. Okay, ytrain is related to xtrain, the one that it will be tested with, it will be trained with, and ytrain, the one that it will be ytest is the one that it will be tested with. Okay, and then I'm going to use the function train test split. I'm going to give it x, y, the test size. So what does that mean is that I'm using, for example, let us say 0, 2, I'm using 20% of my data for the testing. Okay, let us use this. Okay, so let me just add one more thing. Okay, here I want to do this, which is the random state. So I will shuffle my data. Okay, so it won't be in the order, it will be shuffled. Random state, for example, equals to 5. Okay, so this is it. If you want to say what is random state, it is just here the parameter, the train size, the random state. It is default none, so with default it won't random. It controls the shuffling applied to the data before applying the split. Okay, so I need this so that it would choose the testing set in a disordered way. Okay, so I will run this. I have here some. Okay, I didn't run this, and I have my new data sets. Okay, let us see the shapes that I have for xtrain. Okay, so this is my new shape, and the x test will be the rest. Sorry, shape. Yes, okay, so I have 20% of my data to be the testing. Now I will fit my model with only the xtrain. Okay, so here model dot fit xtrain and ytrain. Okay, I fit my model, it's been trained. Now let's figure out the score. So model dot score. Okay, so the score of or using the x test and the y test. So this is my new score, which is a bit less than the previous one, which is logical because here he's testing with a dataset that it doesn't seen in the previous its training. Okay, so I give it y test so that it will compare the original label with the predicted label. Okay, and let's say 70% of the predictions are correct. So I can use different nearest neighbors, different k, so that I will do a bit better performance. Okay, so for example, I will construct this loop for e in range. I will start from 10 to from 2 to 10. Okay, I will try all these numbers of k. Model equals to k neighbors classifier of this number of k. So let me call it k here to be more clear. Okay, so here I'm testing with different k, and I will fit the model with x train and y train. I will print the k. I will print the score, so test score for example, let us say for k equals to k. Okay, so I will remove this and I will put the model score. Okay, so let's see this. Sorry, here I meant test and test. So these are the different scores that I will have using this number of neighbors. Okay. Okay, so I hope that this been clear, but I'm going to specify one last thing, which is how to use this model. So after creating a model, I create a model, I found out, I train it, I found out the score, but how can I use it after this? It's pretty simple. I will create here a function. Let us call it survive. Okay, so I will create a function that giving a model, the model that I built and trained, giving the p class. So I give it the p class, I will give it the sex, I will give it an age of the passenger, and it will give me if it will survive or not. It will predict if it will survive or not. Okay, I will give it some default number. For example, here the class will be 3, the sex will be, for example, 1 as female, the age will be, for example, 25, and I will predict. Okay, so how can I predict? Okay, the model will expect an x. The x will be a data frame or a numpy. Okay, so it accepts both of the types. So I'm going to construct a numpy array that giving these variables that I have, this one, which is p class, sex, and age. Okay, so this is the x. Here we will print, for example, model dot predict x. Okay, so x should be a numpy with shape with 2 shapes. The first one is for the number of samples, and the second one is the number of features. So we know that the number of features should be 3, but we have to reshape this to 1 and 3. Okay, so 3 is the number of columns and 1 is the number of lines. Okay, so we need to reshape it, otherwise I will have a problem. Okay, so here I need to import numpy. Yeah, and this is it. Okay, let us see this. So here, my function will receive the model, the p-class, sex, and age, and it will predict if I'm going to survive or not. So let's call this function survive. That I will give her the model. The other variables are, I'm going to use this default number, so I don't need to specify this here. Okay, if I want to, I will put 3 as the p class, the sex female, and the age 25, and I'm going to see if I'm going to survive or not. And okay, I didn't run this as np, and unfortunately I didn't survive. Okay, so yeah, another detail, if you want to know the probabilities of the models, so I'm going to use here model dot predict proba. We are going to see what this will give us. So this function will give me the percentage of the first class, so it's 0.155 if I won't survive, and 0.4 if I am going to survive. Okay, so it's really close, but it will choose this one because it's bigger than 0.5. Okay, so if I try another one, let's say the first class, I'm a female with age, let's say 12 years old, and I'm going to survive with a percentage of 66% I'm going to survive, and 13% I'm not. Okay, so if I am a younger girl, I will survive from this Titanic disaster. Okay.